Hello, Luke. Welcome to Lesson 52. So today we're going to be talking about two things. The first is addition of rational expressions with unequal denominators, and then the second will be overall average. So let's just dive right in, and we'll start talking about the first one. And this is basically a continuation of what we've already learned when it comes to adding rational expressions with unequal denominators. So recall that a rational expression is just a fancy way of saying a fraction. So if I have a fraction such as this, 6 over xy, all right? And let's say that I am trying to take this rational expression and add it to another rational expression such as 3 over, let's just go with an x squared. All right? And in order to add these expressions together, recall that we need to have common denominators. And do you recall how we found the common denominators? Well, you should. You've been doing a lot of work on these lately. So let's just go through this quickly. To find the common denominator, we need to look at the factors of each of these denominators and pull out the greatest number of individual components within those factors. So what I mean by that is, if we're looking at these two denominators, we recognize that they're dealing with x's and y's. And so we know we're going to have x's and y's in our common denominator over here. So to figure out how many of each, we need to look at each one of these terms and decide which term has the most of each, and then choose to use that many in the denominator. So if we think of the x's, we know we need x's over here. We look at our first term, that has an x to the first power. And in the second term, we have an x to the second power. So there's more x's, you could say, in the second term. So that number of x's is what we'll use in the denominator. So we're going to use x squared. And then how many y's are we going to need? Well, we've got 1 y in this one, and then 0 y's in this one. So the most we're going to need is just 1. All right? So that is going to be our common denominator. And then recall, we then go to the numerator and, well, I should say first, we look at our denominator and we try to decide, or we do decide, what had to be multiplied by this denominator to get it to this common denominator. So you would have to multiply an xy by simply an x to get to x squared y, right? X times x is x squared. We have the y left over, so it's x squared y. So we then have to multiply the numerator by the x as well. And that's going to give us a 6x in the numerator. We then need to do the same thing. We'll add our second numerator here because we have this addition sign here. So x squared is what we have in the denominator. What did we have to multiply the denominator by? We needed to multiply it by a y. So we need to multiply the numerator by a y, right? Because x squared times y would give us x squared y. So now we have 3 times y, which is going to give us 3y. So we end up with this as our final answer to this addition problem. Right? And this is just review. This is totally just review. We're just finding the common denominator. Now, the difference between what we just did and what we're going to do is that now the denominator is going to become a little bit more complicated. All right? So let's pretend, or not pretend, let's look at a problem that is written something like this. Let's go with, I don't know. Let's do a 2 over x plus 1, and we're going to add that rational expression to 3 over x squared. Okay, so in this problem, again, the idea is the same. We want to find the common denominator. So what will be the common denominator for our answer to this addition problem? And to decide that, we need to look at our denominators of the individual terms. And the thing to recognize here, which is different than our first problem, is that here we have a sum in the denominator. if you think about it, all the problems that you've been doing in your seat work where they say, add these terms by finding the common denominator or what have you, all of those have been dealing with only multiplication in the denominator. Here we have x times y. Here we have an x squared, which is an x times an x. We've never had anything that is an addition, a sum in the denominator. They've never done that to us before. So this is kind of a new concept, or not a new concept, but this is a more complicated version of fractions being added with uncommon denominators. So the question is, how do we do this? How do we find the common denominator? And the simple way to think of it is to think of this x plus 1 as kind of being in a set of parentheses, okay? Think of it as being just one bucket, all right? In your mind, you almost have to equate this to maybe just another variable. Just equate it to whatever variable you want. Think of it as like a w. All right, a w just means x plus 1. Okay, that's kind of the way you have to think of this. This is all connected. It's all one piece to the puzzle. All right, and so when in this first example, we looked at our denominators. We said, okay, what are we dealing with in our denominators? And we said, oh, we're dealing with x's and we're dealing with y's. And so let's look at how many of each we need to get our common denominator. Well, here, don't make the mistake and say that, oh, we're dealing with x's and we're dealing with x squared, or, we're dealing with just x's, I guess, really. There aren't any other variables. Don't just say we're dealing with x's, because we're not really. We're dealing with x's, this is true. That would cover this one. But we're also dealing with this whole bucket. We need to treat this whole thing as one entity. That's why I said think of it almost as a w, a completely different variable all by itself. Okay, so we're not just dealing with x's, we're actually dealing with x's, and we're dealing with x's plus 1, or an x plus 1. These are the two things that we're dealing with. Okay, so again, I need to stress this. The x plus 1, we're treating it as if it were one variable all by itself, a completely separate variable. Okay? Think of it as if this was a w, if I were to just kind of cross this out and think of this as a w. So instead we have a w, 2 over w. What would you say over here? We would say, oh, we're dealing with w's and we're dealing with x's. Okay? Well, that's the way we need to think about this sum right here. This x plus 1, we have to think of it as a completely unique entity. It's a variable all by itself, so to speak. It's an x plus 1, and then we have x's. Okay? So when we get to our common denominator, we need to say, okay, that common denominator has to have factors in it from each of these terms. Or I should say, each of these denominators here have to be a factor of the common denominator. All right? They have to evenly go into the common denominator. So if we think of our x's, what's the greatest number of x's that we have here? Well, it's 2. So we're going to have x squared as part of our common denominator. That's going to be one of the factors. What's going to be the other factor? Well, the other factor is well, how many of these x plus 1s do we have? And if we think of that, we have really only one. You might say this whole set of parentheses is just raised to a 1. So we have one of these x plus 1s. All right, so we're going to multiply this x squared by the x plus 1. Do you see now why it was so important to put this in parentheses kind of to begin with? Just to remind ourselves that this is all glued together. It's not going to be x squared times x. I should say it's not going to be x squared times x plus 1. Nope, it's going to be something very different. It's x squared times x plus 1, all in parentheses. Okay? All right, so now just kind of standing back and looking at the big picture, you can see where this common denominator has an x squared in it. X squared does fit in it, you might say. It's right here. It's a factor of this common denominator. And you can also see that x plus 1 is a factor of this common denominator. And that's the way it needs to be. These denominators all need to be factors of the common denominator. So this then is our common denominator. All right, I hope that makes sense. With a little more practice, that should become second nature to you. So if we look at this first fraction, we now need to decide what was this x plus 1 multiplied by to get to this common denominator. And that's pretty clear. The x plus 1 was multiplied by the x squared, right? So we need to multiply this by x squared to get to this common denominator, which means we need to multiply the numerator by an x squared. What we do in the denominator, we have to do in the numerator. So now in the numerator, we have 2x squared in the numerator. All right? And then we have over here this x squared. What do we multiply him by to get to this common denominator? Well, also pretty clear. Here's our x squared. We had to multiply it by the parentheses. We had to multiply it by an x plus 1. So then we need to multiply this 3 by an x plus 1. All right? So here we have this first term, 2x squared. We're going to add that, because that's what we have here, addition. Add that with our next term, which is actually 3 times x plus 1. All right? And that is actually our solution right there. It's kind of messy. It's not nice to look at, but that's our solution. Now, you could, if you wanted to, you could rewrite this in perhaps a little bit more of a longer form, an expanded form, by doing the distributive property for this 3 and the x plus 1, as well as the distributive property for the x squared and the x plus 1. That would be totally fine. There's nothing wrong with that. There's also nothing wrong with just leaving it the way it is. All right? This is a perfectly acceptable answer. Okay? We don't have to always multiply out all of the distributive property terms in the expression. We can leave it the way it is as well. Sometimes it's nicer to leave it the way it is. But just to show that this could be written in another way, I will rewrite it, expanding these distributive property pieces here. So we have 2x squared plus, now if I distribute this 3 through, I'm going to have 3 times x, which is 3x, plus a 3 times 1, which is a 3. And then in the denominator, I'm going to have x squared times an x, which is going to give me x to the third, and then an x squared times a positive 1, which is a positive x squared. So this would also be a perfectly legitimate answer. Either one of these would be appropriate. Okay? All right, so let's try another one here and see how you do. Let's say I've got 3 over y plus 2, and I'm adding this to z over, we'll just go w squared. Okay? So go ahead and take a minute and try to do this on your own on a separate sheet of paper, and then we'll do it together and see how you did. Okay, so let's see how you did. Again, the general concept here is the same. We're trying to find a common denominator. So all of these need to be factors for that common denominator. So the first thing to do is just to ask yourself, even in your head, what are we dealing with here? And I see that we're dealing with w's, and I see that we're dealing with this sum. So since it's a sum, I'm going to go ahead and put this in parentheses to remind myself that this is all locked together as one variable, so to speak. Okay? As one factor might be a better word for it. So we have two factors, the w2 and the y plus 2. So, or I should say the w and the y plus 2. So how many w's do we have? Well, the most we have is 2, so we'll use 2. And then how many y plus 2's do we have? Well, we only have 1, so we're going to use 1 y plus 2. And remember, these are being multiplied by each other. These are factors that we're pulling out, so they have to be multiplied by each other. Don't think of these as being added together. They're always going to be multiplied. All right? Then in the numerator, we have to decide what did we multiply the denominator by to get to this common denominator, and do the same in the numerator. So in the denominator, we took y plus 2 and we multiplied it by a w2. So this is being multiplied by a w2, which means we need to multiply this by a w2, and that's going to give us 3w2 raised to the second power, I should say. We are going to be adding these, so that makes it simple. We'll just throw in our addition sign. And over here, for our second numerator, we have w2 in the denominator. What did we multiply that by to get to our common denominator? We multiplied it by y plus 2. So we need to do the same in the numerator. So we have a plus z times y plus 2. And that is the quickest solution right there. Again, I could expand this and multiply the z through and multiply the w2 through. That's fine, but I don't need to. This is a perfectly legitimate answer right here. Okay? Excellent. All right, let's try another one here. So this one I'm going to pull directly from the book, and we'll see how you do. So if I have 4x plus a all over a plus b, and I'm adding that with c over x. So there are my rational expressions. They're being added together. Pause the video and try to do this on your own. All right, so let's see how you did. So again, we have to find our common factor. So we have, what are we dealing with here? We're dealing with x's. We're also dealing with a sum. Put that in parentheses. So we're dealing with x's, and we're dealing with an a plus b. So what's the greatest number of x's? Well, just 1, so we have just an x. What about a plus b? Just 1, so we have an a plus b. Okay. Now we have to then figure out the numerator. So what do we multiply a plus b by? Well, we multiplied a plus b by an x. So we need to do the same in the numerator. Now, watch out. In the numerator, it also has a sum. This sum we should also think of as being in parentheses, because that'll make all the difference in the world when we multiply it by an x. Now that indicates that x needs to be distributed through. Because remember, we multiplied this whole denominator by the x. We need to multiply the whole numerator by the x. If I didn't put these parentheses, it would look like it was just the a being multiplied by the x, not the 4x. All right, so do you see how important it is to remember these parentheses here? Because that will indicate that x is being multiplied by the whole numerator, not just one term. All right, so the numerator now is going to become, and I'm just going to write it like this. I'm going to write it as an x first, and then it's being multiplied by a 4x plus a. Okay, and then I have my plus sign, and then my second numerator. So I have an x. What did I multiply that by to get to my common denominator? Well, I multiplied it by an a plus b. So I need to multiply the numerator by an a plus b, and that is going to give me a c times an a plus b. All right? And that is my solution. But maybe just to, I don't know, eliminate some of these parentheses, maybe I will expand this one a little bit. You do not need to, but it's an option. So if I expand it a little, I could multiply this x through and get 4x squared plus ax. Do you see how I got that? Multiplying the x through. Plus, I have a c times an a. Well, that's going to give me an ac. And then a c times a b. Well, that's going to give me a bc. All over x times a, which is an ax. X times b, which is a bx. And there we go. I just expanded it. And that would be my solution. This one would work as well. They are both acceptable. All right? Very good. Okay, let's maybe try one more. And again, I'm going to just pull this one directly from the book. So if I have a plus b over x plus c over m plus a d, what would be the sum of this? And why don't you go ahead and pause the video and try it on your own, and then we'll do it together. All right, so let's see how you did. So we want our common denominator. What's it going to be? Well, first off, I might just write this d as a fraction, just to emphasize that this d is in the numerator and not in the denominator. So I'll just write this as d over 1. I haven't changed the value. I'm just writing it as a fraction. And now I can see that what am I dealing with here? I'm dealing with x's, I'm dealing with m's, and I'm dealing with 1's. All right. So what would be my common denominator? Well, what's the most number of x's? I have 1x. I have 1m. And of course I have 1, but the 1 is trivial. We don't need that. 1 would be in everything. So we don't need to worry about the 1. We just have an x and an m. So now we need to decide, what did we multiply things by? So we had to multiply the x by an m to get to this. So we need to multiply the top by an m. Now again, caution needs to be used here. This a plus b should be in parentheses, and we need to multiply that by the m. All right, so we have an m times an a plus b. And then we have our plus sign here. And now for this second term, what did we multiply this m by? Well, we multiplied it by an x to get to this, so we need to multiply the c by an x. So now we have plus cx. And then we have another plus sign here. And now what did we multiply the 1 by to get to xm? Well, that's pretty straightforward. We just multiplied it by an xm. So we need to multiply the numerator by an xm. So it's going to be times a dxm. Maybe I'll put it in alphabetical order and just write it as dmx. Okay? And I might just leave my answer just like that. Now I wouldn't need to. I could get rid of this parentheses here by distributing through the m, but that's all right. This is totally acceptable. So I will just leave it like this. Excellent. All right. Well, hopefully that makes sense to you. It's not very difficult. It's just remembering how to kind of mentally note that these sums are treated as one entity and not as separate ones. After that, it's very straightforward. It's the same process that you've used for quite a while now. So our next part of our lesson today, we're going to talk about the overall average. The overall average. We've talked about averages before. So maybe let's just throw out a couple numbers here. Let's say I've got a 2, a 3, a 2, a 4, a 2, a 3, a 2, a 2, a 2, and a 4. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. That's 10. So let's say I have 10 numbers here, and I want to find the average of these numbers. Well, how would I do it? Remember, to find the average, we just sum all of the individual numbers, and then we divide that by how many numbers there are. So if we sum all these up, we have 2 plus 3 is 5, 7, 11, 13, 16, 18, 20, 22, and 26. So we have 26 in total, if we add them all up. And there are 10 numbers. So the average, maybe I'll write that, average is going to equal 26 divided by 10. Okay? Which is equal to 2.6. So the average is a 2.6. Okay? And you know what? Actually, just to make this a little bit easier for this particular example, sometimes it's nice if we don't have to deal with decimals. So let's just change one of these numbers here. We're going to say that these two numbers actually are going to be 4s. We'll make those 4s. And if I do that, I have 12, 14, 17, 19, 23, 25, 28. Yeah, that gives me 30. So if I add all that up, I get 30. Still the same number of numbers. So I have 30 divided by 10. So my average is going to be 3. There. Just makes it a little bit nicer for this particular problem. Now, let's say that after I had taken this average, I found a couple more numbers that I had forgotten about or lost or whatever. And so these couple more numbers, let's say they were a 5 and a 7. All right? And I go, oh my goodness, I forgot to average those in. And I say to myself, well, how about if I just take the average of these two numbers, which is going to be 5 plus 7, which is 12, divided by, there's two of them, so it's going to be divided by 2. That's going to give me 6. And if I go, okay, well, how about if I take this average of these two numbers and then take that average and kind of combine it with this average, find the average of those two, and decide what that average would be. So if I were to do that, I would have 6 and 3, which is 9, divided by, there are two numbers now, divided by 2, which is going to equal 4.5. Okay? And I would say, well, there's my average. Now, my question to you would be, is this average the same average that I would have gotten if I hadn't lost these two numbers in the beginning? So in other words, if I had just, when I added all these up, if I had added all of these plus these two and found the average for all 12 numbers instead of 10 numbers, would that give me an average of 4.5? So another way to think about it is, the question is the average of the averages going to be the same as the overall average? The average of the whole thing. Would they be the same? Well, let's do an experiment and find out. So let's now find the average of the overall average of everything. So if I have all of these, and these all added up to be 30, and then 30 and 5 is 35, and 7 is 42. So the average here, if I were to do a direct average, or an overall average, I would have 42 divided by these 10 numbers and these two more. That's going to be by 12, right? So what's 42 divided by 12? All right, well, it's going to be what? 36, remainder 6, which is, 1/2. So it's 3.5, or as a decimal, 3.5. Interesting. Notice they're not the same. All right? The average of the averages was not the same as the overall average. In fact, they're quite a bit off. They're off by a whole point in this particular case. Excuse me. So that is the moral of this story. The moral of the story is, you cannot take the average of the averages and expect to get the same number as the overall average. And why is this? It might puzzle you for a little bit. Why would this be? Because intuitively at first it might kind of make sense that if you take the average of the averages, well, that should give you an average that should be equivalent, or at least very, very close to the overall average. And the reason this doesn't work is because the first set of numbers, the black numbers up here, is a much bigger set of numbers. Okay? There were 10 numbers in here. In the second set of numbers, there were only 2. Okay? So if you kind of think of it in terms of that way, the average of this 10 should be weighted more than the average of this 2. So whatever this average of the 10 is, that should play a bigger factor, a larger factor into the overall average than just these 2 numbers. Okay? It's kind of 10 against 2. And so, if you kind of think about it, this 10 should have a stronger voice than these 2. But if we take the average of the averages, Think about what happens here. We took this average and we just compiled it all down into one number. And we took the average of these two numbers and kind of broke it all down into one number. And now each of these numbers is being equally taken into account to decide the average. All right? So the 3, which was based on 10 numbers, gets the same weight applied to it as this 6, which was only based on 2 numbers. All right, they both made up half of our average here. So you can kind of see where that kind of falls apart. You know, if one set of numbers is very large and the other is small, that's why the average does not play out. Okay. Now, just as kind of a thought here, what if these two sets of numbers had the same amount in them? So let's say there were 10 numbers here, and then I found another 10 numbers. All right, so I had not just 10 and 2, but 10 and 10. Would that have made a difference? And the answer is, now that would not have made a difference because they would have been equal in size. Their weights should be the same. In other words, they should each have the same weight applied to them. Their strength is the same. They'd both be 10. And in the end, they would end up with the average of the average would in fact be the same as the overall average. So hopefully I'm making sense here. But basically I'm saying if the two groups are different in size, you can't take the average of the averages and expect it to be equivalent to the overall average. Okay? All right. So that's a concept that they're trying to get across to you. And then what they're going to do is try to create story problems based on this idea. All right, so I'm going to take a problem directly from the book here and see if we can make sense out of it. So let's say that I have 6 numbers, all right? And to designate those 6 numbers, I'm going to use some variables here. I'm going to use n1, all right? This sub number here, this number 1 that sits down in the basement, that doesn't mean anything mathematically. I'm just using that to describe this as the first n, okay? It's just a way of writing it. So the second number I'm going to write as the second n. And then I have, of course, the third n and the fourth n and the fifth n and the sixth n. All right, so I have 6 numbers. I don't know what they are, and that's why I wrote them as variables. But I do know that I have 6, and I do know that the average, their average, is equal to 8. They tell me that, okay? And then they say, well, on top of that, let's say that I, kind of like I said earlier, I found a couple more numbers, and let's say I found 4 numbers. So I'll call these guys maybe a baby n here, or lowercase n, lowercase n1. So I found another number 1, and then a second number, and then a third number, and then a fourth number. So I found 4 more numbers afterwards, and I found that their average is 10. Okay? So the first question they might ask you is, what's the average of the averages? Well, this is the exact same problem that we were doing earlier. So if we have an average of 8 and an average of 10, well, the average of the averages, let's do that in maybe purple. The average of the averages is going to equal 8 plus 10, right? Because that's our two numbers here. 8 plus 10 divided by, how many numbers are we dealing with here? Well, we've got 2 numbers, so it's divided by 2. So 8 plus 10 is 18. 18 divided by 2 is 9. So the average of the averages is 9. But now let's say they want to know, what's the overall average? The overall average. So in order to decide what the overall average is, think about what we would need to do. The overall average would mean we would have to take n1 plus n2 plus n3 plus n4 all the way up to n6, right? So we'd have to take all of those first 6 numbers, and then we would have to add that to our second set of 4 numbers. Okay. And then we'd have to divide that by how many numbers are there total? Well, there are 6 numbers up here, and there are 4 numbers here. So there would be 10 numbers total. All right. This would be the overall average. So how could we figure out what the overall average is? Well, it's actually not too hard if we know the average. The average means that I can replace all of these n's, these blue n's, with an 8. Okay? And that would be equivalent. The sum of those 6 8s would be equivalent to the sum of these 6 n's, no matter what they were. All right? The law of averages, that would tell us that these would have to sum up to the same thing as an 8 being summed with itself 6 times. Okay? So this would be the same thing as this n1 could be replaced with an 8. n2 could be replaced with an 8. n sub 3, I guess is how you'd say that. n sub 3 would be an 8. n sub 4 would be an 8. And I could keep going all the way up through n sub 6. So I have 6 8s. And then I'm adding that to these lowercase n's whose average is a 10. So I can replace all of these lowercases with a 10. So n sub 1 is a 10 plus another 10 and another 10 and another 10, 4 times. All of this would then still be divided by the 10. So I could add all this up, or I could just simply say, what's 8 times 6? Well, 8 times 6 is 48. What's 10 times 4? That's 40, right? All of that over our 10 still. 48 plus 40 is 58. 58 is 88, right? And then 88 divided by 10, that's going to be 8.8. So this is the overall average. Okay? So hopefully you can see how this works. When you're trying to find the overall average, but you don't know the numbers, you can use the average of those numbers, if you know it, to still sum up those numbers. Okay, let's try another problem, and hopefully this will make a little bit more sense to you. All right, so let's look at this problem and try this one out. The average of the first 90 numbers was 4. The average of the next 10 numbers was 6. What was the overall average? Well, go ahead and pause the video and try to do this on your own first, and then we'll do it together. All right, so we're looking for the overall average. So the overall average is going to be everything added up and then divided by how many numbers there are. So overall average is going to be equal to the average. Well, what's the sum? What are all the first set of numbers? What's the sum of all of those numbers? So if we look at the first sentence here, the average of the first 90 numbers was 4. So I would have to say number 1 plus number 2 plus number 3 plus number 4 all the way up to number 90. Number 1 added to each number consecutively all the way up to 90. Okay? Now, instead of doing that, I'm going to say, well, the average was 4, so I can replace every one of those numbers with a 4. And since I'm trying to find the sum of those numbers, I would say that the sum is going to be equal to 90 numbers, each being a 4, is going to be 90 times 4. Okay? So that is the sum of the first set of numbers. Okay? And now remember, when we're trying to find overall average, we're adding all of these sums together. So this is the sum of the first set of numbers. What's the sum of the second set? And we're going to add that to the first set. So we have 90 times 4. The average of the next 10 numbers was 6. So again, I have number 1 plus number 2 plus number 3 plus number 4, all the way up to plus number 10. All right, but I do know that the average of those was 6, so I can replace every one of those numbers with a 6. So I've got a 6 being added to itself 10 times, which would be equal to a 6 times a 10. All right, so this is critical. Hopefully you understand how I'm getting these multiplication problems here, or expressions. The 90 times the 4 plus the 6 times the 10. All right, that would give us the complete sum of all of the numbers being added together. The 90 numbers to begin with, the 10 numbers to end with, the sum of all of those added together would be equal to 90 times 4 plus 6 times 10. So that's the first part of our average, but we need to figure out what's in the denominator as well. That's the sum of all the numbers. What's the denominator? Well, the denominator is the number of numbers we have, okay? So to figure that out, we need to look at our problem here. We have 90 numbers here, and then we have another 10 numbers here. So that gives us a grand total of 100 numbers. Grand total, okay? And that is the setup for this problem. If we can get this far, the rest is easy. So really look at this closely. If you didn't understand how I was able to set this up, rewind and watch it again. So do that until you can clearly see how I got this for the setup. Okay? The next step is simply to work this out. So 90 times 4 is 360, plus 6 times 10 is a 60. All over 100. We can add the numerator here to get 420, and we're dividing that by 100. So since we're dividing by 100, 100 has 2 zeros, so we can simply move that decimal twice, and we get 4.20, or just 4.2 is fine. So we have as our overall average 4.2. Okay? All right, excellent. And notice, if they had asked for the average of the averages, we would have just taken this average of 4 and this average of 6 and added those two together, average of the averages, and divided that by the two numbers. And that's going to give me a 5. So again, you can see how the overall average is very different than just the average of the averages. 4.2 is not the same thing as 5. Well, very good. So hopefully this all makes sense to you. We will stop here today. Good luck with your seat work. Take your time. And maybe before you go to your seat work, make sure that you've jotted down a few notes in your notebook describing what the average is and what the overall average is, so that you can refer back to that when you're doing your seat work. We will see you tomorrow.